Hey y'all. In this video, I want to talk about inequalities and absolute values. So the first half is going to be like inequalities, and the second half is going to be absolute values. So with inequalities, it's basically like the equal sign, except it's connected on one end. So it's going to look like this, or it can look like this, or this, right? So this one means greater than. And these two mean less than, right? So the way you know which is which is, let me see. This one we know is greater than. The reason is because there's like this invisible understood number that's big right here, right? And then this is like a random tiny number. And then over here, when it goes this way, it's understood that there is this little invisible number here that's supposed to be small. And it's just like reading. You know how you start, like, well, in the States, like in the US, when you read a book, let me draw a little bookie here. When you read a book, you start like on the left-hand side and then you just keep going down the page and then you go to the second line and then you start at the very left side and you keep going down the page like that. Right? So you're starting left to right. So you look at the left thing first. So this one's greater than. So a good way to remember it is the greater has 2 dots, less has 1 dot. So back in the day when I was learning this stuff, like as a kid, we did something called the alligator method, so this greater than right here, this was basically the alligator eats the bigger thing. So another way to kind of look at it, if that's a little bit maybe too abstract, maybe you're not into that example, is do you see how like the less than looks like a bird's mouth? Well, birds eat seeds. Those are really tiny. And alligators, they eat fish. Those are really big. They're much bigger than like a seed or a granule. So think about it that way. When you see like the open mouth or the 2 dots, it's greater than because a fish is big. And then when you see the tiny one, I mean, I guess not the tiny one. I guess when you see like the less than symbol, it's like a little bird eating seeds, and those are super tiny, and that's less than. Maybe that's a really good example compared to just an alligator eating the bigger side. So there's 4 different kinds. So we have greater than, we have less than. The ones with a little stick underneath, the little lines underneath, that's called greater than or equal to, right here, or equal to. And then this is called less than or equal to. Greater than, less than, or equal to. It's basically like an equal sign, right? And then one of them is connected, if that makes sense. Equal sign, and then like one of them is connected. So with inequalities, it's pretty straightforward. Like it's stuff you've done before. So this says solve for x, and you have 2x plus 4 is greater than 6. All it's asking you to do is isolate x. So you're going to throw the 4 over, you're going to throw the 2 over, right? You just treat this like an equal sign. It looks exactly, or I guess it acts exactly like this. In my opinion, it looks exactly the same, but obviously one side is like pinched, basically. So it looks like an alligator, and then the equal side is a couple of snakes hanging out. And all you're doing is just throwing the 4 over, throwing the 2 over. And, in the appropriate algebraic method, right? So, you would take that 4 and you make it -4 and you throw it over to the other side, stuff like that. And you basically, you just ignore that symbol. This like greater than, less than symbol, this one's greater than is the one that we're looking at. You basically ignore it. It goes untouched. There's only one time you mess with it and touch it and do stuff to it. And that's when you are either dividing or multiplying by a negative number. That's the only time. And we're gonna walk through it, so you'll see. So we have 2x plus 4 is greater than 6. Okay, so what does that mean? It's saying that this is going to be bigger than 6. Whatever magical number I throw into x is going to be bigger than 6 when I put it all together, right? The x itself, whatever number I come up with, like let's say I want to put a 3 in there or a 7 million in there, that might not be bigger than 6, but we're trying to, everything together, 2 and the 4 and then the x all together is going to be bigger than 6. So let's go ahead and do it. So I'm going to do -4. right? Those are called constants. And what is that? 4 minus 4 is 0. Let me bring down the 2x. I'm going to keep the symbol. And then 6 minus 4, that gives me 2, right? So that's what my setup is. Well, I have to isolate x. So I'm almost there. I'm not exactly there yet. I have to make sure that 2 is by itself, or that x is by itself, rather. Great. So that gives me an x greater than 1, because 2 divided by 2 is 1. This is my final answer. Before I decide it's my final answer, I have to think, did I divide by a negative number or not? Well, this time we divided by a positive 2. So because I divided by a positive 2, that means I keep the symbol exactly as it is. This is my final answer, right? So this is cool. Most people are cool with this as your final answer. But here's the thing. There's a way you set it up, right? And it's the exact same thing, right? That's the exact same thing you set it up. It's called, what was it called? It was called builder set notation. Builder set notation. So when you're messing with these like inequalities, this thing right here where you have like the greater than less than symbol, the way you actually set it up is, I don't know how to draw this. You do a bracket thingy. Well, not a bracket. You do a curly bracket, which looks like this, right? And then you do x, because it's asking you to solve for x. If it said solve for y, you're going to put a y, right? And then you do x. Well, it'll be the same x. I was doing a little fancy x here. It'd be x is greater than 1. And then you close the bracket. Right? So this is also the final answer. These are both correct. This is the more traditional way that they would want it if, like, let's say you were like doing it super like, I don't know, professional, right? If you want to impress the teacher, is what I'm saying, right? If you want to be that guy, this is the method. This is also chill. I mean, they're both cool, right? So I have a really hard time with curly brackets. So what I'm going to do is I might do something like that, right? So I got a surgery on my wrist a few years ago, so I have limited mobility. I'm not ambidextrous. I can only use my right hand. So there's certain shapes, degrees I can't really move. So there's certain degrees I can't write. It's hard to make curves and stuff. Okay, cool. Here is another one. Solve for x, same idea. Let's go ahead and try it again. And our goal is to isolate x, and we only mess with the symbol, the symbol they gave us, which is the greater than again, if and only if it is a negative that we're either dividing or multiplying by. So let's take a look and see how this works. So I'm going to do negative 4 again, right? You always do the constant first, and you mess with the x at the very end. Let's do a line. Let's see, 4 minus 4 is 0. I'm going to bring the 7 down, 7x. I'm going to bring the symbol down. 32 minus 4, 28. 28. Yeah, let me check my calculator. 32 minus 4. Yeah, it's 28. Cool. Okay, it's going to be positive 28. The reason I know it's positive is because 32 is bigger than the negative 4. Great. Now, let's see. I need to divide by 7 because I need to get that x by itself. That gives me x. 27, that's going to be 4. Do I need to flip the symbol? Let's see. I divided by positive 7. So no, I keep the symbol precisely as it is. This is my final answer. If I needed to do it in the builder set notation, builder set notation, I would make it look like curly brackets. Oh no, oopsies. And then it's x, because it's asking us to solve for x. And then we do x, 4, close bracket. Right? So I wonder if I could use a different pen. So this part is the solve for x. This part is our answer. So that's the setup. So it's essentially curly bracket. What is it telling me to solve for? Dots. My answer I came up with, close bracket. So that's what's up. That's it. Let's try another one. Oh, great. This has a fraction. Hooray. Okay, this is solve for x. This solve for x is supposed to be thrown up here. I guess I didn't notice that when I put this together. Okay, so it's saying solve for x. So we have 2, 3x plus 5. Oh, this is greater than or equal to 17. Okay, and we're solving for x. How do I do this? Well, I know there's a fraction. Don't freak out. We're going to take care of this. Okay, we're going to do -5, -5, right? We'll just pay attention to the whole numbers and we'll mess with the fraction in a second. Well, that gives me 0, so we're going to bring down the 2 over 3x. We're bringing this whole thing down. That's 0. Then we have this little guy right here. 17 minus 5 gives me 12. And 17 minus 5. Let me check on the calculator. I don't know why I'm struggling today. Okay, yeah, it looks like I got it right. Okay, perfect. So now we have this fraction. What do I do? Well, remember, every time you have a fraction against a whole number, you want to put that invisible 1 underneath the whole number. That way it's two fractions and it's a little bit easier to look at. Okay, and then we have to get x by itself. All you do is just invert the fraction that you're having to get rid of. Not the 12 part. That stays. We don't touch him. And we do the 3 over 2 again. That's the inverted one. This is inverted, and this is that same inverted. Right? Because we're going to cross these out. And let's see. It gives me x. And then I have 12 times 3 is 36. And then I have 1 times 2 is 2. And then what does that give me? Let's go ahead and do that again. So it gives me x, same side, 18. This is my final answer. I did do some multiplication, but it was a positive number. I didn't have to flip anything over. And if I had to do this builder set notation, what does that look like? Curly brackets. It's asking me to solve for x. 2 dots. X. The answer. There we go. This is also the correct answer. When I was first learning how to do curly brackets, I was in high school and I had this teacher. She was really mean, and I did my curly brackets like this. Not like this, like this. And I did it on notebook paper. And I kind of grew up, I would say poor. I grew up kind of poor, so I didn't have enough notebook paper in the house. It just wasn't. It wasn't a resource available in our family. My parents really weren't like interested in like education and stuff, so it wasn't a priority in the home. So I would cram all my little numbers onto one single line. You see how like this curly bracket is like coming out? So she saw that. She would get so angry. She was convinced that I had upside down backwards 3s, and that's what I was trying to do, like I didn't know math or numbers. So she would take points off, twice the points, for putting 3s here and putting 3s here. So every single answer she would take 2 or 3 points off. So I suggest to you guys to learn your curly brackets if you have an instructor that's very, very particular or bitter, let's just say. Okay, so let's see. I'm going to try to make curly brackets like super fancy with this one, if I remember by the time we get there. Okay, so we're going to solve for x. Let's do -3, -3. Okay, those are called constants. Anytime there's a number naked hanging out by itself, it's a constant. This x is called a variable, and this number up front, if there's like a number in front of an alphabet, in front of a variable, it's called a coefficient. There's probably like an extra letter somewhere in here. Okay, cool. So I'm taking the constant 3 and moving it underneath the constant 7. That gives me a 0, so we'll get rid of that. So it leaves me with -2x, and I'm going to leave the symbol as it is. That gives me a 4, right? 7 minus 3 is 4. So here's a really good example right here. So we're about to divide, right, to get that x by itself. what do? Okay, I get rid of those 2's. I have an x here, and then 4 divided by a -2 gives me -2. That is my answer, but I have to think about it. I have this symbol here that it looks like it's greater than because it's facing the left side, but I divided by a negative number. If I divide by a negative number, I have to take this guy and I have to place him flipped over like this. So this is my final answer. Anytime you are dividing, here, let's write it down. Anytime you, that's you, divide, or multiply, let's do this for multiplication, by a negative number, you gotta, let's do gotta, flip the sign. Okay, great. So anytime you do that, you gotta flip the sign. And we're gonna do set builder notation, so let me try to do it fancy. Okay. There we go. And then we're solving for x because it told us to. And then the answer, which we flipped that sign over. And then we do -2 because that was our actual answer itself. Oh, geez. I don't think I did a good job. Okay. This is also the answer. So this piece of information is super important. So anytime you're dividing or multiplying by a negative number, you got to flip the sign, okay? It has to happen. Because here's what's up. If you don't flip the sign and you keep it as is, your instructor might be chill and be like, okay, I kind of see what's happening. Let me give you some points because you did technically get like the correct like answer that's -2, and you know we're talking about solving for x. So, okay, you know what? I'll give you like half the points or 80% of the points. But you're going to have an instructor that says because the sign is wrong, the whole thing is wrong, and they're going to take off full points for the whole entire problem, right? So you're going to get instructors that have like no chill. They're going to be super strict about it. So just remember that you never touch the sign unless you're dividing or multiplying by a negative number. That's the only time you mess with the sign. Let's do one more problem. Okay, this one's a really good one. It's kind of elaborate. See how there's like 4 of them? Okay, so we're going to solve for x. I want to, let's move this over. Like, let's move this here, and we'll just put this here by itself. Okay, so we have 4 things going. You see how there's 4 of them? So don't get like too worked up about it because we can totally like break it down small pieces. So let's move the x's together and we'll move the constants, which is the 6 and the 21 together. How do I do that? I'm going to do -6 and I'm going to do -6 here, right? That way it's guaranteed we're going to get rid of these 2 6's, right? So what does that give me? Let's go ahead and do it step by step. I have 5x. That's a 0, so he's just a 0. I'm going to bring my sign down. Then it gives me 2x. And then 21 minus 6, that's 15. That's plus 15, right? That becomes 15, right? So now what do? Maybe we can get rid of that little 0. Okay, so that's my new like setup right here. This guy's my new setup. Let's see, now I got to get rid of the x from the right side. That that 2x, I got to move it over to the other side. Okay, that's a 0. That's 15. We're going to bring that down. 5 minus 2 is 3. 3x. Well, great. Wonderful. Let's see. What do I do now? Because I have 3x is greater than 15. Well, I got to get rid of that 3 because I got to get x by itself. So we get rid of x. We got rid of 3, and then we have x left over. How many times does 3 go into 15? It goes in 5 times. Right, 5, 10, 15. Do I move the sign? Do I change it? Do I touch it? Let's see. I divided by a +3. This was +3. So it looks like no, I don't. I don't mess with it. totally leave it alone because the only time I flip the sign is if I'm either dividing or multiplying by a negative number. It has to be a negative, guy. It can't be positive. Cool, so this is the final answer. If I have to do it in what we called builder set notation, that's going to look like this. I'm going to have my little curly bracket. And then we're going to do this guy. This is just the standard. This is like a fancy way of doing X. It's the same thing as just like the X's we've been doing. And we're just going to copy what we wrote down. And I'm going to close it. Okay, this is going in a weird direction. Okay, all right, there we go. These are both the same exact answer. So if you guys want to study your curly brackets, you might want to, I'm sure there's something online where you can learn how to make it really attractive. So with inequalities, you just treat it exactly like this algebra stuff, like where you're throwing everything on one side. You treat it exactly the same. In fact, pretend that equal to, I mean, the greater than, less than sign, just pretend it doesn't even exist and just do it like you normally do. The only time you have to pay attention to it existing is if you either divide or multiply by a negative number. You gotta flip the sign, right? Because we can't just leave it as is because we don't know what kind of point system your instructor is going to have if you forget that little detail. So the only new information you learned with inequalities is basically about the sign flippage. And there's only one procedure what you have to follow, which is did I divide or multiply by a negative number? That's all you had to remember with this inequality stuff, basically. And I guess builder set notation, I guess you had to kind of know that. But I think I've only had one instructor that forced me to do that. And that was in college. That wasn't like a high school thing. So with absolute value is always going to be positive. So a lot of people like absolute value because of that. So it's always positive. It's always happy. So no matter what you do to it, it can handle it. It can handle the pressure. So if I give you like a 0, by the way, these two little lines, that's absolute value. Anything I put in there is going to be a representation of absolute value. These little sticks, they're just two sticks. This is going to be 0. If I put a like a 7 in there, guess what? It's positive. You don't got to do any math. That's it. That's the answer. Okay, but what if it's a -7? What about now? What's the answer? It's going to be +7. It negates the negative sign. It's always going to be positive. It comes out positive. But what if I give you -18 and I put it in absolute value form? Okay, cool. That's just 18. That's it. It's always positive. So the three, like in your textbook, or like your lecture notes or something, if its absolute value has 3 basic guidelines. If it's a 0 inside the absolute value, it's going to be straight up 0 because it's kind of neutral. It's not exactly positive. It's not exactly negative, right? So they included 0. And then if it's a positive number, this is a variable. This is variable. It's just a placeholder. It's supposed to be just like some random number that's positive. If it's positive, guess what? It's going to be positive. It's just going to come out positive. If it's negative, it's negative. If it was like -7, -2 million, -18, it's always going to come out positive. So that's kind of the game here. Another way to look at it, here, let me erase some of this. Get rid of a little bit of this guy here. Another way to look at it is if it's 0, it's always going to be 0. If you have a positive number, on the number line, where it's like 0 and then it's positive here and then it goes negative on the left side. So if it's positive, it's all this stuff here into infinity, let's call that. X is going to be greater. Your absolute value stuff is going to be greater than 0. And if it's negative, it's also going to be greater than 0. And that's important because no matter what you put in here, it's always going to be bigger than 0. What's bigger than 0? 1, 2, 3, 4, 7, 14 million. Because it always comes out positive. So what's on the other side? If I'm saying it's 1, 2, 3, what's on the other side? Well, 0 is here, and then we got -1, -2, -3, -4. These guys, they're not going to show up to the party. It's always going to be positive, right? No matter what you throw at it, all this negative stuff you throw at it, this -4, this -2, this -18 million, no matter what you throw at it, it can handle the pressure. It's always going to come out positive, okay? So that's what absolute value is about. It's absolutely always happy. You gotta think of it that way. Cool. So let's do some examples. Let's see. So here's a couple of examples. I have -9 and I have +6. And these are absolute values. So what would that -9 be? And remember, it can handle any pressure you throw at it, and it's always going to be positive. So it's going to be the final answer of 9. That's it. That's my answer. There was no math. What about the 6? It's +6. Well, nothing really happened, so it's just 6. That's it. It always comes out positive. It seems pretty straightforward, and I mean, it is. It really is, but sometimes it gets a little bit more elaborate. Stuff like this. Okay, cool. So what would this be? I have -3 plus 2. So the placement of these absolute values, like the little placement of the sticks, is kind of important, right? So we'll walk through it together. What is -3 plus 2? What is that final answer? What does it give me? Here, let's put these brackets up. It gives me -1, right? -3 plus 2 is -1. So what's the final answer? Is it -1? Well, it can't be -1, right? It can't be. It can't be -1 because it always comes out positive. It's going to turn into +1. Let's think about it a different way. You're essentially solving the problem inside. We answer the question inside the little bracket thingies, the little sticks. Well, it's supposed to come out positive every time. So it finalizes to this. This is the answer. With the final answer, you're not going to have the absolute values, the little sticks. They disappear. What about the second problem? I have -6 minus 6. Let's do the sticks. -6 minus 6 gives me -12. What's my final answer? It's going to be +12. Right? So what I did is I solved the answer, and then I turned it into something positive because it can handle the pressure. It turned into -12, and then it changed to positive. So there's kind of like 2 steps. What about here? 4 minus 8. That gives me -4. 4 minus 8. What does it turn into? It turns into +4. You see a theme? This was +1. This was +12. This was +4. In my other one, it was +9 and it was +6, right? So you're seeing a pattern. It's always positive. It can handle whatever you do. It's going to turn out positive. Let's do a few more. Do you see how in the previous one, we had the sticks on the outside right here? Okay, well, now the sticks are kind of random. A lot of people find these to be a little bit more easier than the ones that weren't just on the outside. So let's work on them one at a time. What is this positive? This is a -5. What does it give me? It gives me +5 plus 3. I moved it over to here. What does that give me? What's my final answer? 5 plus 3 is 8. That's my final answer. I'm done. I can move on to the next problem. So I have a -5 here again. So what does it turn into? It turns into +5. The whole thing is not negative or positive. We were just focusing on the -5 because that's where the sticks were located. Right? So what does it give me? It gives me 14. That's my final answer. What about this? I have -6 minus -8. Well, let's see. I have a -8 here, so it's going to be 6 minus +8. Right? This turns into a positive. This negative is from here, right? I can't do anything but keep it. I have to keep it as is. So what does that give me? Let's see. That's going to give me a -2. But here's the thing. That is, in fact, the final answer. It turned into a negative. Why did it turn into a negative? Why did we not just get rid of it? Well, because right here, I have it. Let's bring it down. I have this 6, and then I got this negative. This whole entire thing became positive. Once you turn it into a positive, you can get rid of the brackets. It doesn't exist anymore. Like if you were an alien that came from another planet and you had this problem right here, this 6 minus absolute value of -8, and I showed this to you, and you had to work on the problem, you would do 6 minus +8, right? And then you would immediately you would forget about this because you're like, oh, cool, I already moved on. I'm an alien. I don't have the ability to recall the past. So that's gone. So now you just look at 6 minus -8. Well, what's my final answer? -2, right? There is no more absolute value anymore. So that's how you got there, because you're an alien and you don't recall the past, but you recall numbers. So there you go. It's interesting how aliens are. All right, cool. So that's all the examples. So sometimes they get tricky. You know, the problems get tricky. Just the best advice I could give is work on it super, super slow. Even if you think like you're going slow at a rate that's embarrassing, it's cool. Don't worry about it. Just keep doing it. Because, you know, at the end of the semester and you get a good grade or a better grade than you wanted, you're not going to look back and go, oh, I spent an extra 8 minutes on that homework that one time. You're not going to look back thinking that in a negative way. So just go ahead and take it slow. It's no big deal. Like, it's cool. And then over time, you'll get faster because you took the time in the beginning to really grasp it. So the secret is everyone does math slowly. So I promise everyone does if you just actually watch people. Okay, I hope this helped. So we studied inequalities and absolute values in this particular video. And I do have stickers in my sticker shop if anyone's into that. Or don't. Don't look if you don't want to. Okay, thanks guys. Bye.